Good afternoon, everybody. Let's get started. For announcements, we will be starting Lab 9 this week. So we're going to be working in lab on the IoT and MQTT topics with your project in order to make your aircraft electric motor test bed internet enabled. So you'll be able to control the test bed over Wi-Fi, and you'll be able to report your sensor data and view it on a PC. And exam 2, I'm still grading it. Hope to have that done by now, but I'm still working that. So I will get those graded and post those grades and let you know when that's done. All right, so during the previous class, I started the introduction of Internet of Things and MQTT. And so today we're going to continue IoT and try to finish that up today and then move on to radio frequency topics. Okay. So taking you back a couple slides, I want to set the context to continue this conversation. So we're talking about communicating using this pub-sub architecture over a network. And I was showing examples using Mosquito. Mosquito is a software that implements MQTT clients and a broker. So the broker is running on this PC over here, and I have some laptops, could be PCs. Running clients to publish messages and then subscribers that receive those messages. And these lines of text here, these are command line commands in like Windows command prompt or PowerShell, or you can do this in Linux as well. So I wanted to continue talking about this, how to send these messages between PCs and laptops, but also point out that this can happen between non-PC devices like microcontrollers and other devices. And then I talked about these control packets. So what goes on behind the scenes of that, what's happening in the command line, these packets are sent between the clients and the broker and the server. And so you have to, the client has to connect, the broker has to act, the client or the broker can publish. And so there are these control packets being sent behind the scenes. And I want to remind you of that because we're going to take a look at some of the bytes in those packets just to show you what's happening behind the scenes. Okay, so let me show you a way of publishing and subscribing on a PC. And this applies to our lab because you're going to be publishing and subscribing using a PC as well as using your test bed. So these Mosquito clients, so these are MQTT clients, the software is Mosquito. You can download that for free. You're going to do that during lab. The Mosquito clients have options to support monitoring topics, monitoring messages, observing the protocol to see what's going on, what's being sent back and forth each time you send a message, and also debugging messages. Okay, so here's an explanation of the commands that are available through Mosquito. So there's one command, one piece of software, this client software, mosquito_sub, and it offers these options. So typically you at least have to specify a host, and that is the address of the broker, either an IP address or the URL of that broker. T is the topic to which you want to subscribe. And so you can actually subscribe to multiple topics. There are also these options like -D. This enables the debug messages that shows what's going on behind the scenes. You don't normally have to look at that, but if you want to see the messages going back and forth or you're trying to debug some problems, you can enable this option. -I is an identifier that you can assign to your client through the command line or not. It defaults to some text appended with a process ID. So you don't have to specify that. -V prints the messages verbosely. And what that really means, it's going to show you not only the message, but the topic associated with that message. Let's suppose you subscribe to multiple topics and you want to see, well, which topic, over which topic did this message come? You can use the -V. I'll show you examples of this. So that's how you subscribe on the command line using different options. To publish, you do this. You use mosquito_hub, and you have these options. And in blue, this is typically what I use. -H specifies the host or the IP address or URL of the broker or of the computer running the broker. -M is the message payload that you want to send, and -T specifies the topic to which you want to publish. And again, you can enable debug messages to see what's going on behind the scenes, the multiple packets going back and forth between let's say a publisher and a broker. -I, again, it's optional. You can specify an ID, but if you're looking, let's say you're looking at packets going over a network and you want to identify your client, you can specify an ID that you recognize, or you can filter on IDs on the other end. And then you have an option to read messages from the command line that such that you can just type messages, hit enter, they get sent. So each time you hit enter, a separate message gets sent. Okay, so those are really easy to use, powerful clients. You're going to use these to look at the sensor data coming from your test bed, to watch what your test bed is publishing, and also to publish to your test bed to command RPM, for example. So your test bed's going to be sitting over on the bench. You can command it over the internet using this. It's a really powerful tool. So here is an example of publishing and subscribing on a PC. Here's the protocol flow. So what I'm going to do is I'm going to bring up a whole series of lines here in the command line, but concentrate on the top line here. So this was, I typed in at the prompt mosquito_sub and the rest of this text, and I hit enter, and then all this other stuff appears. But what I did to subscribe was I used mosquito_sub -H. I subscribed to test.mosquito.org. That's a public broker out there that's run by the Mosquito organization. You can just use it when it's up for testing. And I specified a topic with -T. My topic is test_topic_1. I just made that up. I turned on the debug messages so I can watch debugging happening. That's -D, verbose -V, and I gave my client a name, -I, Bill's subscriber. And then this happens, so you can see what's happening behind the scenes. So this client, my client that I named, sent a connect packet to the broker. It's looking to connect to the broker so it can establish that connection and subscribe and get those messages from the broker. The broker then sends back, and this client receives a connection acknowledgement, this CON-ACK here. So now the client knows that it is connected, at least for now, to the broker. And then you could see, well, I said through this one line, I wanted to subscribe. So next, the subscribe packet gets sent, and here's the topic and the quality of service. I didn't specify one, so it's assumed to be 0. We'll talk about that in a bit. And there were some options in that packet that are all set to 0. And then the broker comes back and says, okay, I received your subscription. I'm acknowledging the subscribe message. So now what happens is it sits here. This command line sits here and waits for a message to be received from the broker, waits for another publisher or a publisher to publish a message to this test topic 1. So it's just going to sit there and wait. Okay, so all that's happening. So this is all that I described here. Okay, and then every once in a while, the subscriber would like to know, hey, broker, are you still there? Because if someone unplugs the PC or stops the broker software, you'd kind of like to know, if you're a subscriber, that there's no more data coming and maybe handle that condition. So every once in a while, this subscriber sends out this ping request to verify that there still is a connection to the broker, and the broker says, yes, I'm here, is the ping response. So you could set that time, and it might happen every minute or 2 or 10 minutes. It doesn't matter. You can set that. But then you know, okay, the broker's still there. I still expect to receive messages through this subscription. Okay, so then those pings might happen over and over again. But let's jump down to the the publishing client. So now I open up another command window, another PowerShell window, and I type this in, mosquito_pub-h. There's the URL of the broker I'm using, that public test broker there. -I, I'm just giving, you don't have to do this, but I gave myself an ID for this client. -D, turn on debug messages. These are the debug messages, what you're seeing, all these packets, these indications of packets being sent and received. Those won't show up if you don't specify -D. Then here's the topic. I'm using the same topic, that test topic 1, and my message is, in quotes, hello world. Okay, so I'm sending that. And then so what happens, I execute that, I hit enter, and then you can see, well, this client also has to connect to test.mosquito.org, connects to the broker. The broker software running at that server responds, yes, I acknowledge your connection. And then the client actually publishes the message. So I, on my PC, that command window, publishes using these options here. And here's the test topic, and those 12 bytes and hello world exclamation point are sent. And then I'm done publishing here. So the client disconnects and the command line prompt comes back. But in the other window where I was subscribed, you can see that, well, I've received here, subscriber received a message. It's a published message. The publication came from the broker to the subscribing client with these options to this topic, and those 12 bytes, hello world exclamation point, were received. Here's the topic. The verbose option prints out that topic, and you see the message right after that. So that's the anatomy, that's the flow of just starting up 2 command prompts, subscribing in one command prompt, publishing on another, and seeing what's going back and forth there between the clients and the broker. This can be on 2 different PCs. So you could start this up at home, your friend on another PC that's connected to the internet. If you both can get to this broker, test.mosquito.org, you can both send data back and forth to each other over the internet. Your devices can send data back and forth. You can have a home control system, make up your own home control system, or for multiple homes, or across, from your apartment to your whatever, your home somewhere, and you can send these messages over the internet. It's pretty easy. Okay, so I've shown this on a PC, but this does not have to be limited to PCs. So you can write software. You can use the command line interface like I just showed, but you can also write software in Python and C and whatever. You can use some client software tools to send messages. And you can run the broker and client software on laptops and desktop computers. You just have to be connected to some network that may or may not be connected to the internet. In lab, you're going to do both. You're going to connect to a broker on the internet, and we're going to use a standalone network to connect to. So we're on our own network in lab to send messages back and forth. So it's isolated. But also beyond PCs, you can use just microcontrollers that have some kind of network enabled. In other words, you have Wi-Fi like our board in lab, or you have some kind of interface that connects you to wired Ethernet. Okay, so your applications then that run on the microcontroller have network connectivity over MQTT if they run these client libraries. Okay, there are also some integrated modules, which are still, I would still consider them microcontrollers because they're running some microcontroller software on there. But some really neat ones that I've used, and they're low cost, are this ESP8266, ESP32, this Node MCU. They're like $5 a piece. They're amazingly cheap, maybe even less now. But these are low cost, open source hardware platforms that you can use. They have integrated Wi-Fi, all built on the antenna and the Wi-Fi module, and you can program them, many of them, with the Arduino IDE. So if you can program this Arduino Uno, then you can program these similarly and use the client libraries that are available either on the Arduino website or GitHub or wherever. If you want to be more like a single board computer, or use a single board computer hardware platform, you can use something like a Raspberry Pi or other single board computers. And this takes you up a notch. This gives you an operating system, and it's on Raspberry Pi, it's typically Linux. So you have that command line interface that you can run in Linux. You can also write software applications that run maybe C or whatever that run in Linux, and again run MQTT clients or brokers. In lab, I'll show you over in the corner. I plugged in a Raspberry Pi and a network switch. There's a wired connection here. It's actually a Wi-Fi router. And this Raspberry Pi is running the broker. So that's the broker that you're going to connect to for the standalone network is running on this Raspberry Pi. It's running the Mosquito broker. Okay, so so you can use this whole kind of ecosystem. Lets you use microcontrollers to interface MQTT communications using pub and sub with sensors. So you can have analog peripherals, you can have temperature sensors, moisture sensors, whatever, a network of sensors connected to these modules that connect to Wi-Fi or wired Ethernet, and sense things. And you could also have distributed computing too. So you might have multiple single board computers in the same room at different parts of the country, it doesn't matter. And you can send data back and forth to distribute the computing between processors. So it's a really powerful way to exchange data, distribute computing, and integrate sensors. Okay, and it's simple. I use this because it's simple. It's easy to, it's very easy to use, and it's free. Okay, so let's talk about using MQTT on Arduino compatible devices. So either something like the Arduino Uno Wi-Fi that you're using, or those ESP modules that can be programmed with the Arduino IDE. All right, so there are MQTT libraries for integrating this pub/sub data exchange into programs instead of using the command line. So I showed you the two command line examples. Well, if you're gonna run a microcontroller and have like your test bed controlled over the web, over the internet, over a network, and send data over the network, then you probably want to run these libraries as part of your program. So there are open source libraries for programming applications under Windows, under Linux, under the Arduino IDE. There's lots of different ways to do this, but it all exists. You don't have to write it from scratch, which is nice. For the Arduino, this is the library that I use and you will be using in lab. So this is the pub/sub client library. You download this into your IDE and just use it. There are other libraries. Here's the Arduino MQTT client, and you can find different libraries on GitHub. So typically you choose a library and you develop your code using the library functions and classes. So you'll see example code in lab. But for example, this set of software or the program, this library here, it's in C++. It has these constructors for an object and these functions that you use. So you might recognize these from the process that we just talked about of connecting, disconnecting, and publishing and subscribing, and more that we didn't talk about. So here's how you can connect using that C function. You can disconnect, you can publish. Let's see, what else can you do? Subscribe, unsubscribe, and then have certain callbacks that are triggered when events happen, like a message is received. Okay, so lots of stuff there. You don't have to use all these functions. You'll see examples where just some of these functions are used just in a minimal application. And then you can test. So I go back to the command line now. You can test using the command line clients. So Mosquito has those built-in subscription and publishing clients. And so if your microcontroller is sitting there waiting for some data, you can send it. You can send it data and do testing, or you can receive the sensor data and see what's coming out using these command line clients. When you're using an Arduino, you need some kind of network connection between the Arduino and, well, the network. So we're going to use Wi-Fi. We're going to use this Wi-Fi Nina, maybe that's how it's pronounced, to connect to the Wi-Fi in the lab. Okay, so you're going to use this library. So you'll wind up installing PubSub client and this library here, and then running the software, and you'll see how all this works. And all that template code can be used for your future projects as well. Okay. So let's talk about the topic. So I've been saying, a subscriber subscribes to a topic, a publisher publishes a message to a topic, then the subscriber receives that topic. Well, there's a powerful way to use these topics using wildcards. So MQTT topics themselves are text strings. So it's just text, like I've been showing you. And they filter the messages for the connected client. So the broker is only sending those messages to the clients, to the subscribers that have subscribed to those topics that it specified. So a topic itself consists of one or more levels separated by a forward slash. Now this forward slash and these one or more levels, this is all optional. You can just specify one level, a topic, temperature, publish and subscribe to that topic. But you can also use these levels of topics and also wildcards, which I'm going to show you. So here's some example topics. You could have just temperature. I want the temperature from a sensor that publishes to temperature. But you could also separate with these separators. So I could have, well, my home might have a dining room, and that dining room has a temperature sensor in it. Okay, or my home has a couple floors, and I have a bedroom on floor 1, and it has a temperature sensor. So you can organize your topics like this. Or my home on floor 1 has a bedroom and it has a humidity sensor. So this is how you organize. And typically I use this rightmost text after the slash as really the most detailed value that I want access to or I want to subscribe to. Okay. Floor 2, bedroom 1, humidity. So you get the point here. And you can do something like this. Mosquito Pub, here's the publishing client to this broker. And I'm going to publish to the topic, aircraft 1, left engine oil temp. Right? Message is a number, 195. And you might have like left engine and right engine, or you might have left engine, oil pressure. So you can have different organizations like that that describe where the data is coming from. It makes it useful in a way I'll show you. Don't forget, topics are case sensitive. So if I have a capital A here under aircraft, in aircraft, that's different than lowercase a. So be careful with that. And also avoid using leading slashes like this, because when you have a leading slash, what this tells this client is that, oh, there's a null or a 0 character that is actually the leftmost level. And so typically you don't do that. So because that can mess you up, because /house/temp is different than house/temp. They're not the same topics. And also I typically try to avoid using spaces in my topic. If I need to separate words and make them more readable in a topic, I'll put underscores. You can use spaces, but if you use spaces, you have to use quotes. And if you forget the quotes, your command looks like it should work and it doesn't, and it's giving you an error. So I typically try not to use spaces, but you can do this. And I can do this right here. Messages often have spaces. So if you have spaces in a message, you have to put quotes around the message text. All right, I mentioned wildcards. Here are wildcards. These are available for subscribing to multiple topics all at once by specifying one topic string. Okay, so there are two different kinds of wildcards. Here's a single level wildcard. So it works like this. So for example, I can subscribe to my home separator slash ground floor slash this plus. This is the single level wildcard slash temperature. Okay, so if I subscribe to that topic, then here are a set of topics that I would either receive or not receive. So you can see my home slash ground floor slash, here's where the wildcard is, the single level wildcard in living room slash temperature. So this matches with this pattern up here with the single level wildcard. I can change living room to kitchen and get the kitchen temperature because that kitchen is taking the place of that wildcard. Okay, but if I have my home, ground floor, kitchen, and brightness, that does not match the pattern of this topic with the wildcard because I have brightness instead of temperature. So that won't match. I won't receive that message. Or first floor instead of ground floor. Right, you won't receive that. Or let's see what else here. Fridge instead of temperature. You won't receive this message or the messages associated with this topic because of the extra level in here. Right? Even though there's temperature at the end, kitchen matches up with that single level wildcard, but fridge does not match up with this temperature. Okay, so that lets you subscribe to multiple topics, and you could think of how you might use that when you have a microcontroller publishing multiple data values or multiple microcontrollers publishing, and you want to receive from multiple microcontrollers. So multi-level wildcards look like this. They always go at the end. So my home slash ground floor will subscribe to these messages. You will receive these messages. Anything with my home, ground floor, and anything after ground floor, that slash, will be received by the subscriber. But my home first floor, because that doesn't match ground floor, won't be received. Okay, so this lets you organize your data in some rational, logical way so that you can, or I should say, organize your topics so the data arrives in a way you want to receive it. Okay, so let's practice with this. Let's run a clicker question. So grab your clicker apps and let's use wildcards. So which topic string will subscribe to all of these topics: measurement slash RPM, measurement slash RPM slash average, analysis slash RPM slash average, but not these topics. So you don't want these topics. Right? You don't want messages from these topics. And remember, plus is a single level wildcard and pound hashtag is a multi-level wildcard. Okay, so oops, yeah. Give you some options here. Okay, so which one of these will receive these top messages, or I should say receive messages associated with these top topics, but will not receive messages associated with these bottom topics? Okay, so let's talk about this. Okay, so let's look at A. So A, measurements slash pound here, only measurement topics and not analysis topics will be received by the subscriber. So I wanted to receive this one here, analysis slash RPM slash average. So A won't do that. B has this leading slash here. And so I don't have a leading slash, that's bad practice anyway, leading slash on any of these topics that I want to receive, so that won't work. C, so you can't do something like this. You can't add logical signals signals, logical symbols in your topics to do this. That's not part of the protocol. That won't work. And also, you cannot use the multi-level wildcard at the beginning. You can only use that at the end of a topic with multiple levels. So the answer is D. So at the first level, any topic will be received. At the second level, only topics with RPM at the second level will be received. So that will exclude temperature down here. And then anything after the third level or later, you can have anything. So that's why these three will be received, but these will be filtered out. Okay, so you will work with this in lab. What you're going to do in lab, you're actually going to put a team name. So you're going to name your team name it anything, and you're going to so that when you publish, you can filter on your own team name to see your data. And if you want to look at your another team's data, you can put their team name in, but all of the data is going to be filtered by team names at the top level. Right? Okay. I mentioned quality of service, and it's worth mentioning in case you have an application or a future project that relies on reliable communications, reliable data coming over MQTT. In other words, not missing any data. So MQTT quality of service, QoS, is actually, it's an agreement between a message sender and a message receiver, right? The sender can be a broker or a client. The receiver can be a broker or a client. And this agreement defines the level of delivery guarantee for a specific message that is being sent. So there are 3 levels of QoS in MQTT. A QoS 0 is called at most once. QoS 1 is at least once, and QoS 2 is exactly once. And I'll describe these. So these different quality of service selections are a balance between reliability of messaging and efficiency. So in other words, it's a balance between guarantees of delivery and data required, or the amount of data required and the amount of messages or packets sent back and forth. Okay, so QoS 0 would look like this. Let's say you have a message sender and a message receiver, right? Either one of these can be, so the left side can be a client, the right side can be a broker, right? If the sender is publishing, or the left side can be a broker if it's sending a message to a client. The right side can be the client. Okay, so if you publish using QoS 0, what it is, it's another word for it, or another term is fire and forget. The sender's going to send a message and forget, just assume it gets there. Okay, and that message might not be received. There's no guarantee. If there was some network problem, then maybe the message doesn't get there. So that's QoS 0. QoS 1 does this. The sender publishes a packet, right? It's the publish packet specifying the field QoS as number 1. And once the receiver receives that message, it says, oh, I received it, and I'm going to acknowledge that publish, and it sends a pub ACK back to the sender. Okay, so you think, well, you publish and you get the acknowledgement, so everything worked out well, right? But duplicate messages might be received. For example, if the message sender sends publish with QoS 1, the receiver receives that, it sends back an ACK, a pub ACK, and let's suppose the sender misses that pub ACK for some reason. Then the sender thinks, oh, the receiver didn't receive my message, so it's going to send the publish message again. So you might receive duplicate messages using QoS 1. For QoS 2, this happens. So this is the exactly once. So you go back to the left here, right? The QoS 0 at most once, right? Fire and forget. QoS 1 at least once, could be twice, could be more. Duplicate messages could be received. QoS 2 is exactly once. So the sender publishes using a publish packet and specifying QoS 2. And then the message receiver says, yes, publish packet received. But the receiver wants to know, okay, did the sender actually get my pubrec message? So the sender sends back, yes, I received the pubrec, and then okay, publication's complete. So you see it took, instead of one message for QoS 0 or I say messages, instead of one packet for QoS 0 or two packets for QoS 1, it took 4 here. So there's more data being sent over the network, and it's so it's less efficient from a data perspective, but it guarantees delivery. And this is guaranteeing that the message was received exactly once, but it does require more data and more time. So it's a trade. Okay, so the client that publishes a message to the broker defines the QoS level. Okay, so if you're a client, you publish a message, you define the QoS level for that message during transmission. The broker then transmits the message to a subscribing client using the QoS level defined by each subscribing client, right? So the subscriber can define itself its QoS level. And if the subscribing client defines a QoS lower than that of the publishing client, the broker will transmit the message at the lower QoS level. Okay, so when you're a publishing client, there's no guarantee that the subscribing client is going to receive your message. You can only guarantee that the broker is going to get your message. And so you use QoS 1 when you have a, let's see, oh, I've got to fix these. This is QoS 0. So use QoS 0 when you have a reliable network connection and you can tolerate a few dropped messages. You use QoS 1, got to fix that, when you need to get every message but can tolerate duplicate messages. And you use QoS 2 when you cannot tolerate dropped messages or duplicate messages. Okay, so consider that when you're sending data back and forth between nodes in your project. Okay, so here's a protocol example. So if let's look way down at the bit level. We're going to exercise your hex conversion knowledge here too. When I publish a message, right, ABC, to this topic, elect class, using this broker, and you use a program called Wireshark. Wireshark, it lets you look at the raw packet data on a network. So you can download this for free and use it and watch network comms, sniff network comms. So you can see what happened. When I hit enter, you could see that I sent from my IP address to test.mosquito.org's IP address. And then you can see the information that's sent. There was a connect command, a connect ACK, a publish message packet, and then a disconnect. And if you look at the publish message, this is the protocol. So while you're digging down into the bits, if you wanted to see what's going on there, you could see there's a packet type for the publish packet. That's type 3, binary 110011. And then here's where the QoS level is specified. And there's a retain field too that you want to know about that. Let's talk during office hours. And then the remaining length of the message of the data that's in this packet. And then you can decode these bits, or show these bits, I guess, and talk about the decoding of these bits. But so let's see. Here's the here are the bytes of that network frame. So right here, here is the what we're calling the MQTT packet right here. You can see that we have a publish message and Wireshark's decoding this for you, right? So this is the data that's decoded in that publish message. You can see right here, this is, where is it there? Let's see, X30. So, okay, so 3, the first nibble is a 3. Testing my hex knowledge here too. So the first 4 bits right there, that's a hex 3. And then the rest of the bits are 0, 0, 0, 0, 0. So this is QoS 0, right? And then 0F is the remaining length. F is a hex 15, right? Or decimal 15. Hex F is a decimal 15. And so those are the remaining bytes here. So the topic, which here is elec underscore class, is specified here. These are ASCII values, right? ASCII values are a way to represent characters in a byte. And then here's the message, ABC, in ASCII values. So this is all happening behind the scenes. You can look at the data in hex and see how it maps to the protocol, how that maps to the messages, how that maps to what's going on with the client software. Right? And so here's a case. I mentioned that software engineers often don't want to look at binary values. Here's a case where you wouldn't want to look at these ones and zeros, right? Instead of B0 here, you would have 8 bits and you'd have a lot of data to stare at. Whereas here you can identify the byte and just do the translation in your head to bits. Okay. All right, so you can actually run your own MQTT brokers. There are several public brokers on the web, but some of them have limited capacity. They give you limited throughput and maybe limited amount of messaging. And sometimes they become unavailable for some reason. They just go offline. But there are MQTT broker services available for a fee. So if you're running a business, you can subscribe and have a guaranteed service from a service provider over the internet. But there are also, if you want to run your own hardware and your own software, free open source brokers that you can run on your Windows or Linux computer. That's what I'm doing in lab. If you download Mosquito, you're downloading a broker as well as clients. Right? So if you download this executable, install on Windows, you can run the broker as a service or manually start the broker. So in PowerShell, here's an example. I just typed in mosquito-v. V shows the messages or the kind of status messages, what's happening. I type that and my computer's running a broker. It's just sitting there waiting to be to have clients connect to it. Or you can also do the same thing on a Raspberry Pi. So you can install the software. Up top, this is Windows. You run an installer. In Linux, sudo apt-get install Mosquito and the Mosquito clients, and that will you can run this as a service. So when you boot up your Pi, it just runs. And that's what we have in lab. We have this running in the corner, waiting for you to connect to it. Okay, and then you configure both of these brokers using a file. So if you look in this mosquito.conf file and you get into the documentation on the Mosquito webpage, you can see how to set up different options. Okay. So talking about security, when you move beyond your academic projects or your hobby projects, you really do want to consider security, maybe even for your projects. But there are 3 approaches to security, so people can't get your messages or control your project. So here are 3 ways. There's network level security. So you could actually set up a VPN between your client computer and your server computer that's running the broker. You could do that. You could set that up. You could set up transport level security. You'll hear that called TLS SSL. And that encrypts your data between your clients and your broker. And it also offers authentication, so you can authenticate clients. Okay, and there's application level security, and that's built into MQTT. That uses client identifiers. Remember, you can specify client IDs and usernames and passwords. Um, that's a good idea, but the thing is, if you sniff with Wireshark, if I sat there in lab and sniffed with Wireshark and I looked at the packets that you're sending, I can find your password. So right here, I actually set up a password, and you can see that. Let's see, I said, what was right here, I decoded my password right here, right? So that can be sniffed. So passwords can be sniffed when you're not using SSL. Something to consider if you need security. All right. Okay, so that's MQTT. We talked about running MQTT and just pub sub in general on microcontrollers and PCs and single board computers. It has its place over wired and wireless networks, but there are other options. For example, if you need to communicate between devices and maybe hubs, you might consider Zigbee. Zigbee is the low power wireless mesh network standard. It's an IEEE standard. And this standard targets battery powered devices, so devices with limited energy, and typically wireless and monitoring applications. So if you're trying to control something wirelessly, or you're trying to monitor a sensor, and you have a Zigbee system, a Zigbee hub, possibly, then you can use Zigbee. An alternative to that is Z-Wave. Z-Wave is a protocol. It's used primarily for residential and commercial automation, so home automation or building automation. And it's another mesh network protocol using low energy radio to communicate device to device. Okay, so it's forming a network device to device and device to hub, so that I can make multiple hops to get data to the destination. And it interfaces with hubs, and some of these hubs have MQTT bridges. Like I use the Smart Things. This is a Smart Things hub here. I think it's called something else now, but there's someone wrote some software, so you can actually integrate if you have some MQTT devices running on Arduinos and you want to get that data into your home control system. Maybe you make some kind of LiDAR sensor that you're putting at your front door, or your level sensor on your garage door, or something like that. You can send messages using MQTT and get those messages to your home control system to integrate with all of these other devices that use Zigbee or Z-Wave. So there's integration potential and capability with MQTT and these hubs. LoRa is for longer distances. So this is a network protocol for transmitting raw bits, so raw data over a physical link between network nodes, and it's longer ranges. And so I haven't used LoRa yet. I'm really looking to find a problem, looking for this solution. But the advertised range is usually listed as many kilometers. I've seen 10 kilometers advertised. And so if you have a true line of sight, you might reach these ranges. You can watch some YouTube videos on people who have actually tried this. Sometimes it's shorter, but it's definitely longer than Wi-Fi or Zigbee or Z-Wave. You'll see something called LoRaWAN, which is actually a cloud-based protocol that manages the communications between end devices and the network for IoT. And then, of course, there's good old Bluetooth. So if you need just short-range wireless communications for data, audio, sensor data, whatever, you can use Bluetooth between fixed devices and mobile devices over fairly short distances, as I'm sure you're aware. Okay, so to summarize IoT and give you some takeaways. So IoT is there, it's available to make network connections fairly easily between sensors and computing devices and human interfaces. And so you can add remoteness to your projects. It's often used in sensing, in control, and automation of buildings, automation of really anything over local area networks and over the internet. And I talked about MQTT, which is a free open source, lightweight protocol for communicating between devices, and it uses a broker, requires a broker in the center of this publish subscribe approach. And then you can use Mosquito as the software. It's free, it's open source, on your clients as your broker to communicate via MQTT. And there are a lot of low-cost hardware platform options out there. So you can get Arduinos, Arduino-like devices, other microcontrollers, Raspberry Pis, other single board computers, small laptops, whatever, to communicate using IoT. Okay, so I hope this opens up your mind to ideas, how you might connect your projects simply using free software and or even distribute computing. I've played with that before. It's really neat to be able to distribute computing between devices, but I hope that gives you some ideas there. So we're going to close it here. We're going to end with IoT and MQTT here, and next time we're going to talk about radio frequency technologies. We'll leave that for next time. So don't forget Lab 9 this week. You're going to put IoT and MQTT into practice. Check Canvas for the due dates and due times of the assignments coming up and just the whole schedule in general. I will start office hours right after this lecture. So if you'd like to stick around and talk, please do so. If not, I'll see you next time. Have a great night.